Orion's historic journey around the moon, scientists find a field full of meteorites from an asteroid explosion over South Australia, and China's aggressive confrontation with the Philippines to steal space junk debris from a Chinese rocket. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Artemis 1 Orion spacecraft has arrived safely in lunar orbit. It's now well into its distant retrograde orbit, which will take the mission some 92,195 kilometres beyond the Moon, further than any other human-rated spaceship. The orbit's called distant in the sense that it's high in altitude above the lunar surface, and it's retrograde because Orion will be travelling around the Moon in the opposite direction to the way the Moon travels around the Earth. It's a highly stable orbit that requires very little fuel to maintain. Last Monday, Orion swooped to within just 129 kilometres of the lunar surface before streaking out to its new distant retrograde orbit. The manoeuvre saw Orion travel behind the Moon as seen from Earth, resulting in the expected loss of signal with NASA's Deep Space Communications Network for about 34 minutes. And the signal was reacquired as expected as soon as the Earth came back into view. During its mission, Orion undertakes numerous course correction engine burns. They're designed to keep it pointing in the right direction, and there are some longer orbital insertion burns designed to move the spacecraft into and out of its distant retrograde lunar orbit. So far, the data is showing that Orion's used a lot less fuel than expected, and all spacecraft systems are continuing to operate nominally. In fact, the only drama for the mission so far was a sudden unexpected loss of signal for 47 minutes between Mission Control and Artemis 1. That was last Thursday. The dropout happened just as NASA's Johnson Space Flight Center in Houston, Texas, was reconfiguring the communications link between Orion and the Deep Space Network. The issue was quickly resolved, and the spacecraft remains in a healthy configuration. Engineers are now analyzing the data to determine exactly what the cause was. Meanwhile, there has been a little bit of drama with one of the CubeSats launched by the Artemis 1 mission. NASA's Lunar H-MAP CubeSat, which was designed to measure the distribution and abundance of hydrogen and, by extension, water ice in the Moon's south polar region, failed to perform a crucial manoeuvre as planned. The CubeSat was supposed to undertake an engine burn during its lunar flyby, but it failed to do so, most likely because of a stuck valve in its propulsion system. Mission managers are still hoping to salvage the 10 CubeSat water hunting mission because Lunar H-MAP's other systems all appear to be functioning nominally, and heating the valve might well free it, bringing the propulsion system back online. There are 10 other CubeSats on the mission that are all deployed from the SLS's upper stage following separation of the Orion spacecraft after it left Earth orbit. They're all performing nominally. The 25.5-day Artemis 1 mission is considered the final test for the Orion spacecraft and SLS launch system, which will carry humans back to the Moon in 2 years' time and return people to the lunar surface in 2025. Orion will also form part of the spacecraft, which will eventually take people onto Mars and beyond. But that won't be for at least another decade or so. This is SpaceTime. Still to come. Scientists find a field of meteorites from an asteroid explosion over South Australia, and NASA's planetary defense team successfully predicts an asteroid impact. All that and more still to come on SpaceTime. Scientists have discovered one of the largest meteorite-strewn fields in Australia. The 6-kilometre-long ellipse fall zone, located north of the outback South Australian town of Port Augusta, was created by the airburst of a large meteor about 1.5 metres wide back on July the 31st, 2013. That airburst was originally detected by US Department of Defense satellites as an unusually large atmospheric explosion, equivalent to approximately 220 tons of TNT. However, details were only made public recently after the United States began releasing bolide event details from their archives. So, 9 years after the 6-ton asteroid crashed through Earth's upper atmosphere, scientists using a combination of satellite data, weather radars and drones began searching the strewn field looking for fragments of the doomed space rock. And over just a few days, they found more than 44 small meteorites. The field team, led by Professor Andy Tompkins from Monash University's School of Earth, Atmosphere and Environment, found their first samples just 10 minutes after arriving at the site. Tompkins and colleagues have now gathered over 4 kilograms of meteorite samples and have commenced the process of studying and evaluating their finds. He says the discovery is exciting because it's the first meteor-strewn field resulting from a new fall event to be defined since the famous Murchison meteorite fall in Victoria back in 1969.
Back in mid-2013, a 6-ton asteroid basically hit the Earth's atmosphere, moving at about 20 kilometres a second, and exploded and showered the ground with lots and lots of meteorites. And basically what's happened is defence satellites have picked up the explosion, and sometime later that data's been released to the public. And then the guys at Curtin University, led by Hadrian Deverbois, have used that information to try and track down the place on the ground to go and hunt these down. And then we've basically gone out to the place and walked around in the desert and picked them up.
Now, I know that saltbush country pretty well. How did you find them? This is not like finding a meteorite in Antarctica where the black rock sticks out against the white background of the snow, or even in the Sahara Desert where, again, the black meteorite sticks out against the yellow sands. This has got to be a more difficult job.
Yeah, it's a bit trickier. So you're kind of largely right, though. They are black rocks. Because they're newly fallen meteorites, they tend to have quite a dark, almost black surface. And there aren't very many rocks that are that sort of distinctive black colour that meteorites have when they're really, really fresh. So in this particular case where it happened to be this time, there was some sand, the usual red sort of coloured sand of the Australian outback, a bit of grass around and that sort of thing, which makes life harder, some shrubbery, and there were lots of small rocks around too. And so a lot of the small rocks just happened to be sort of tan-coloured, light brown-coloured. So there weren't very many black rocks around at all. So picking up the meteorites amongst all the brown rocks wasn't too hard. The tricky bit, though, was there's lots of kangaroo poo and a bit of sheep poo around the place as well, which made they all look like meteorites. So that made life a little bit harder. Wasn't too bad.
Ah, dear. Well, I'm sure you would have known the difference as soon as you touched it.
Yeah, the meteorites aren't as squishy.
Yeah. You found a fair few of them. Tell me about it all.
Yeah, so we've got 44 meteorites so far, and they sort of come from what we call a strewn field, which is kind of like an ellipse-shaped region on the ground where the meteorites are scattered after the explosion in the atmosphere. So we basically went out there and started to walk a grid across the area, and then we started finding meteorites, and then everything, our planned grid sort of went a bit chaotic and everybody started wandering around everywhere picking up meteorites. It was just too much fun. So it hasn't been fully searched out yet. What we've done is kind of gone in there with drones too to try and make it a bit easier for ourselves as well. So yes, 44 meteorites so far, lots still to find probably. It's going to be interesting to see how well the drone technology helps us really refine things as we keep going back there to try and find some more.
On average, average being a subjective word, I guess, what size are they?
Yeah, so the biggest one we found so far is about as big as your fist, and the smallest one is maybe about a couple of centimetres across. We expect there to be some bigger ones out there still, so maybe the size of your head type size meteorite is about as big as they're likely to be out there. Most of them are probably sort of half the size of your fist, or maybe a bit smaller than that. So yeah, that sort of range so far. We'll see how we go with finding a few more.
Back in 2013, when the actual airburst took place, did anyone report it? Or was it just a place so far away from what we call civilization that no one actually noticed it?
Yeah, that's a good question. So obviously the defence satellites picked it up, like I said before, but I would imagine some people would have seen it. But what did pick it up was the weather radar system. So once we had seen that there was a big explosion in the NASA data, Hadrian went along and looked at the weather radar data and was able to spot the level in the atmosphere where the radar actually picked up the meteorites coming through the atmosphere. And that helped him triangulate on the ground where the best place would be to go and look for it. So it was actually the weather radar that recorded it probably the best and helped us the most. And it was Hadrian's work calculating where on the ground they would be as a result of that led us to the right place.
Was the Desert Fireball network set up at that time?
Yeah, so this was actually just before the Desert Fireball network got set up properly. So we weren't able to use the Fireball cameras at that point. This was kind of the case of just being able to use the weather radars. And in the future, what we hope we'll be able to do is to use the weather radar and the Fireball cameras to sort of refine the trajectory, even better we can just with the cameras alone, to figure out where it came from in the solar system. So figure out the orbital location in the solar system where it came from. Yeah, that's what we're hoping will happen going forward.
You'd be able to tell some of that from the shape of the ellipse on the ground. You'd have a rough idea, wouldn't you?
Yeah, we did actually, Hadrian did actually calculate the orbital origin for this, but the amount of error on using the approach of just using the weather radars was produced a little bit of an unrealistic orbit. We think it probably came from somewhere in the asteroid belt, which is between Mars and Jupiter, but the orbit calculated was a little bit beyond Jupiter, so probably a little bit out.
What sort of meteorites are they?
We've had a look with the microscope and the electron microprobe already, and it looks like a H5 ordinary chondrite, which means it's a fairly common type of meteorite. Lots and lots of metal in it, so it's a type of stony meteorite. Type of stony meteorite with lots of metal. They're quite magnetic and lots of little chondrules in them. Probably the research we're doing on it is not to do so much with what the meteorite can tell us about the early solar system in this particular case, but a few other interesting things like little bits of metal, little bits of iron sulfide, and minerals like olivine and pyroxene as well. They're fairly typical of what a normal stony meteorite looks like.
So where are we at now? What's happening now?
Yeah, so on this last trip we went out there, we took some drones with us. So Seamus Anderson from Curtin University has been doing research on using drones to speed up the meteorite hunting process. So what happens is he takes the drones, flies it over the area in a grid pattern, and takes thousands of photographs of the area from there. And then from the resulting thousands of photographs, he uses artificial intelligence to search through the photographs for meteorites. And the program goes through, picks out meteorites, and gives the searchers targets to go and follow up on. So basically, it should cut down the time for searching by a lot. It might take days and days and days to search out a hunting area for many people, whereas this gives you targets straight away. You just walk straight to the meteorite, basically. So it's pretty exciting.
That's Professor Andy Tompkins from Monash University's School of Earth, Atmosphere and Environment. And this is SpaceTime. Still to come, NASA's planetary defense team successfully predicts an asteroid impact, China's aggressive confrontation with the Philippines to steal a piece of space junk, and later in the science report, scientists finally work out why people get fluffy floaties and stinky sinkies. Yes, we're going there. All that and more still to come on SpaceTime. In the early hours of Saturday, November the 19th, the skies over southern Ontario, Canada suddenly lit up as a tiny metre-wide meteor streaked across the sky high in the Earth's atmosphere and broke apart, scattering into dozens of small meteorites over the southern coastline of Lake Ontario. Now, small asteroids like this hit the Earth's atmosphere all the time. But what makes this one special is that it's only the sixth space rock to have been successfully detected in space and identified as a potential Earth impactor before it hit. The meteor, catalogued as 2022 WJ1, was detected by NASA's Scout Impact Hazard Assessment Team 3.5 hours before the impact. NASA is tasked with the detection and tracking of much larger near-Earth objects which could survive passage through the Earth's atmosphere, causing damage on the ground. But those objects can usually be detected much further in advance than small ones like the asteroid that disintegrated over southern Ontario. Now, these small asteroids are not really a hazard to Earth, but they can be a useful test of NASA's planetary defense capabilities for discovery, tracking, orbit determination, and impact prediction. Near-Earth Object Observations Program Manager Kelly Fast from NASA's Planetary Defense Coordination Office says the event demonstrates response readiness for short warning events. These harmless impacts become spontaneous real-world exercises, allowing NASA's planetary defense system to test its capabilities in the event a larger, more dangerous asteroid presents itself. It's a fascinating story. The asteroid was first discovered by the NASA-funded Catalina Sky Survey, which is run by the University of Arizona in Tucson. The detection was made during routine search operations for near-Earth objects. The observations were then quickly reported to the Minor Planets Center. That's an internationally recognized clearinghouse for the position measurements of small celestial bodies. And that coordinate data was then automatically posted to the Near-Earth Object Confirmation page. NASA's Scout Impact Hazard Assessment System, which is maintained by CNEOS, the Center for Near-Earth Object Studies at the agency's Jet Propulsion Laboratory in Pasadena, California, then automatically retrieved that new data and began calculating the object's possible trajectory and its chance of impact. CNEOS calculates every known near-Earth asteroid orbit in order to provide assessments of potential impact hazards in support of NASA's Planetary Defense Coordination Office. And so just 7 minutes after the asteroid was posted on the confirmation page, Scout had already determined it had a 25% probability of hitting the Earth's atmosphere, with possible impact locations stretching from the Atlantic Ocean off the east coast of North America all the way down to Mexico. More observations were then provided by the astronomical community, including citizen scientist astronomers in Kansas. These better define the celestial coordinates of asteroid 2022 WJ1, its trajectory, and its possible impact location. Small objects like this can really only be detected once they're fairly close to the Earth, so if they're headed for an impact, time is of the essence to collect as many observations as possible. And this object was discovered early enough for the planetary defense community to provide more detailed observations, which Scout then used to confirm that there would be an impact with Earth and predict where and when the asteroid was going to hit. As Catalina continued to track the asteroid over the next few hours, Scout used this new data to continuously update the asteroid's trajectory and the system's assessment of the chance of impact, posting those results on the Hazard Assessment System's webpage. Many astronomers check the Scout webpage throughout the night in order to determine the most important asteroids to track. And a group of citizen scientist astronomers at the Farpoint Observatory in Kansas decided to track the asteroid for more than an hour, providing crucial additional data that enabled Scout to confirm with 100% accuracy the impact probability and where and when the location of atmospheric entry would take place, that being over southern Ontario at 3:27 a.m. With still more than 2 hours remaining before the impact, there was lots of time to alert scientists in the southwestern Ontario region of the bright fireball that was about to occur. Some 46 observations of the asteroid's position were ultimately collected, the final one being only 32 minutes before impact by the University of Hawaii's 2.2-metre telescope upon Mauna Kea. Then, right on time as predicted at 3:27 a.m., asteroid 2022 WJ1 streaked through the Earth's atmosphere in a shallow angle, breaking apart and likely producing a shower of small meteorites, but leaving no reported damage on the ground. Dozens of sightings were reported to the American Meteor Society, and scientists who were alerted to the Scout prediction were able to photograph the asteroid's atmospheric entry. Videos of the fireball collected by the public were also posted online, and NASA's Meteorite Falls website also reported weather radar detections. Now, as we said at the top of the story, this was only the 6th time that an asteroid was observed in space, which was predicted to eventually hit the Earth. The first asteroid to be discovered and tracked well before hitting the Earth was 2008 TC3, which entered the atmosphere over Sudan and broke up in October 2008. That was a 4-metre wide asteroid, which scattered into hundreds of small meteorites over the Nubian desert. The last to be detected prior to the Ontario event was earlier this year, when asteroid 2022 EB5 entered the Earth's atmosphere over the Norwegian Sea, Scout accurately predicting its location and time of impact. Of course, all these things are happening in the Northern Hemisphere. South of the equator, there is still no comparable asteroid detection and warning system. A Chinese Coast Guard vessel has twice blocked a small Philippine Navy rubber patrol boat before forcibly seizing a large piece of space junk debris believed to have come from a Long March 5B rocket which had fallen to Earth in Filipino territory. Chinese naval vessels have been harassing these small Filipino supply boats in the South China Sea for years, but stealing material in possession of another nation constitutes a far more brazen act by the ruthless Beijing government. This confrontation in Filipino waters is the latest in a growing list of heated disputes between Beijing and its neighbours, including the Philippines, Vietnam, Malaysia, Brunei, Japan and Taiwan. The metal debris at the centre of the confrontation was just one of numerous pieces of space junk from a Chinese Long March 5B rocket, which had launched back on July the 24th, carrying the final module of Beijing's Tiangong or Heavenly Palace space station. The problem is, China deliberately allow their Long March 5B rockets to fall back to Earth in a chaotic, uncontrolled re-entry, unlike other nations which control the descent of their rockets, targeting a region known as Point Nemo in the southeastern Pacific Ocean, well away from populated areas and trade routes. Because of the chaotic nature of the Chinese re-entries, rocket debris can come down pretty well anywhere. Previous Chinese Long March 5B rocket debris has plummeted back to Earth, landing in the Maldives, Borneo, and on several villages in the Ivory Coast. The Philippine Navy says Chinese space junk has been discovered in Philippine territory on at least 3 separate occasions. The Philippine government has sent a letter of protest to Beijing over this latest incident, telling reporters they won't let China trample over Philippine maritime rights. The Philippines and other nations in the region have repeatedly protested over China's increasingly aggressive stance in the area. In response, the United States, Australia, Canada, and the United Kingdom have deliberately taken their warships and military aircraft through the region under international freedom of navigation laws in defiance of often shrieking threats by Beijing. This is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.